The Forms of Matter are Numberless, a short essay written and read by Bruce Mills, otherwise known as the Obligate Pedestrian. I apologise in advance for my pronunciation of Greek, Latin and French. From the Introduction to A Dictionary of Chemistry and Mineralogy with Their Applications by Andrew Ure, MD, FRS, 4th edition 1831. I also don't know whether it's Andrew Ure or Ure, but I had to make a choice. The forms of matter are numberless and subject to incessant change. Amid all this variety which perplexes the common mind, the eye of science discerns a few unchangeable primary bodies, by whose reciprocal action and combination this marvellous diversity and rotation of existence are produced and maintained. These bodies have resisted every attempt to resolve them into simpler forms of matter, are called undecompounded, and must be regarded in the present state of our knowledge as experimental elements. It is possible that the elements of nature are very dissimilar. It is probable that they are altogether unknown, and that they are so recondite as forever to elude the sagacity of human research. The primary substances which can be subjected to measurement and weights are 52 in number. To these, some chemists add the imponderable elements light, heat, electricity and magnetism, but their separate identity is not clearly ascertained. End of quote. In particular, Andrew uses the term experimental elements. This is a significant point. Until quantum chemistry, there was no method other than axiomatic assertion to be entirely certain that any material was elementary, that is, prima materia, prime material, fundamental material. I am using the term prima materia here in a generic sense to mean that which is prime, elementary or fundamental, and not as a specific reference to any of the presumptions about this in various texts over the centuries. The idea of the elements is the idea of the ancient Greeks, that there is some materials that are never created, never destroyed, and form the infinite variety of observed materials by combinations. But it is not clear what those are. Humans struggled for centuries to come up with the definitive collection, and even there it was only experimental elements in the sense of that which we have not yet managed to break apart. From the late 19th and into the 20th century, it was learned that so-called elements were not elementary, that they were composed of protons, neutrons, electrons and photons, these fundamental particles being the more elementary. But by then the term element had become fixed in the language as pertaining to being prime in respect of the chemical operations. The term element then took on a much less elementary role than was originally intended by those who created the term. One can nominally remove this linguistic problem by saying chemical elements, those materials that are elementary under chemical operations. Andrew continues as follows. Of the 52 ponderable principles, 4, possibly 5, require distinct collocation from the marked peculiarity of their powers and properties. These are named chlorine, oxygen, iodine, fluorine and bromine. These bodies display a preeminent activity of combination, an intense affinity for most of the other 47 bodies, which they corrode, penetrate and dissolve, or, by uniting with them, so impair their cohesive forces that they become friable, brittle or soluble in water, however dense, refractory and insoluble they previously were. Such changes, for example, are operated on platinum, gold, silver and iron by the agency of chlorine, oxygen or iodine. But the characteristic feature of these archaeal elements is this, that when a compound consisting of one of them and one of the other 47 more passive elements is exposed to voltaic electrolyzation, the former is uniformly evolved at the positive or vitro-electric pole, while the latter appears at the negative or resino-electric pole. End of quote. A point to notice here is that the language being used in this exposition by Andrew is halfway between what is often said to be alchemical notions and what is said in the 21st century to be chemical. For one thing, he calls the experimental elements ponderable principles. and he talks about them as having an unusual power to penetrate and unite with other such principles. This is linguistic evidence for a gradual evolution of thought from one conceptual point of view to another, taking centuries to complete. Andrew goes on to discuss the theory of combustion and to some extent to deconstruct his earlier discussion of the special role of electropositive elements and to attack the validity of Black's doctrine of latent heat. But following this would take us too far from the focus of this essay, which is the theories put forward by Robert Boyle in 1661. It is worthwhile to note, however, that Andrew attempts what is clearly a prototype of the idea of classification that eventually led to the construction of the mostly modern periodic table in the late 19th century. Robert Boyle published The Skepticchymist in 1661. It is written as a dialogue. After the introductory preface, Boyle begins with, "Physiological considerations touching the experiments want to be employed to evince either the 4 peripatetic elements or the 3 chemical principles of mixed bodies," mixed with an X. Note, in particular, his use of principles to refer to salt, sulfur and mercury, 2 of which are the 19th century chemical elements, and the other one is a simple ionic compound. Later he uses the more general term, the primitive ingredients of bodies. After a lot of pleasantries, in the persona of Carnitis, Boyle begins in this manner. "Notwithstanding the subtle reasonings I have met with in the books of the peripatetics and the petty experiments that have been showed me in the laboratories of the chymist, I am of so diffident or dull a nature as to think that if neither of them can bring more cogent arguments to evince the truth of their assertion than they are wont to be brought, a man may rationally enough retain some doubt concerning the very number of those material ingredients of mixed bodies which some would have us call elements and other principles." End of quote. Note that the elements and principles have been declared synonyms. The main point in the 21st century term is that the number and nature of the chemical elements is hard to determine and at that time quite ambiguous. Indeed, Boyle suggests, through Carnitis, that the number of opinions on the matter is quite as much as the number of materials observed, and the crucial problem is that fairly much all practical bodies are composed of multiple elements. Isolation of the pure elements is very difficult, and indeed purification of the elements was a very core interest of the medieval alchemists for precisely this reason. To study the element, one is advantaged by having it in its pure and singular form. Boyle asserts that he is not convinced of any of the arguments for specific sets of elements as made in the literature up to the writing of his book. The protagonist of the report of the dialogue is a fictionalized Boyle who states, "I cannot but promise myself that I shall before we part either lose my doubts or the hopes of ever finding them resolved." I won't read the next few pages, though I was sorely tempted. They are such an eloquent way of saying, "My opponent's argument is empty rhetoric," which, when it comes down to it, is what almost everyone claims. Eleutherius then states that Aristotle, the writer of the original organon, was the greatest master of logic who ever lived. Aristotle also wrote the book which named the topic physics, and that he artfully deduced the numbers of the elements from evidence and logic. Actually, the task of deducing the number of elements is very difficult. We believe that with quantum mechanics we've pretty much done it, starting from Schrödinger's equation, but it is a highly non-trivial task. It is still 300 years in the future from the time of the skeptical chymist and required much more advanced mathematics than was available at the time. Even just a pragmatic empirical list took some 200 years. The argument for the 4 elements is essentially that when wood burns, it is decomposed into the solid ash, the water that sizzles out of the ends of the wood, the smoke that rises into the atmosphere and merges with it, and the flames themselves. There are several errors of logic here. Firstly, it is not strictly known whether the burning is a decomposition process, phlogiston being emitted, or a composition process, oxygen being absorbed. And there is no logical need that in a composition process the object itself is not torn apart, And another is that even if one could show that the wood was breaking into 4 distinct materials, this does not prove that those 4 materials do not in their turn break into yet more materials. This is not at all to suggest that the theory presented by Aristotle is in some sense a non-starter, only that it is close to impossible to prove from the evidence available in the 17th century that the elementary materials are earth, water, air and plasma. The evidence is suggestive, but a long way from conclusive. In hindsight, we see the theory is incorrect. My own bias here is to claim that the 4 elements are essentially stand-ins for the 4 phases of matter, solid, liquid, gas and plasma, but for that to work it seems likely that allotropes abound. To be honest, I sometimes have trouble figuring out who is speaking in this dialogue of Boyle's. The dialogue is not set out as in a play, but rather it mentions at some point by Boyle as a narrator that so-and-so speaks. It seems that Themistius now says, "For this doctrine is very different from the whimsies of Chymist and other modern innovators, of whose hypothesis we may observe, as naturalists do of less perfect animals, that as they are hastily formed, so they are commonly short-lived. So these, as they are often framed in one week, are perhaps thought fit to be laughed at the next, and being built perchance but upon 2 or 3 experiments, are destroyed by a 3rd or 4th, whereas the doctrine of the 4 elements was framed by Aristotle after he had leisurely considered those theories of former philosophers which are now with great applause revived as discovered by the 3 later ages, and so judiciously detected and supplied the errors and defects of former hypotheses concerning the elements, that his doctrine of them has been ever since deservedly embraced by the lettered part of mankind, all the philosophers that preceded him having in their several ages contributed to the completeness of this doctrine, as those of succeeding times have acquiesced in it." End of quote. Themistius has a point. A lot of changes occurred in Europe during the 17th century, with multiple theories being proposed, abandoned, rediscovered or modified. Newton was not the first person to suggest the inverse square law, nor F equals ma, and a lot of changes happened in material science. For one thing, the technology of pumps had improved, and Hooke invented the vacuum pump, which was something like the particle accelerator of the 17th century. Many people did experiments with the behaviour of low-pressure gases. This caused quite a kerfuffle. Themistius then goes on to personally insult the intelligence of those who he dismisses as being dirty empiricists. A curious resonance occurs with this in the play Rosencrantz and Guildenstern Are Dead by Tom Stoppard of the 20th century. Rosencrantz: "Why don't you go and have a look?" Guildenstern: "Pragmatism? Is that all you have to offer?" The objection raised by Carnitis is more along the lines that Themistius has not proved that the elements of fire and water were components of the wood, as they might be created during the process of combustion, seeming to suggest that the wood and the water are both combinations of the truly prime materials, rather than any of them being prime themselves. That all that is seen in the experiment of combustion are mixed materials, or in modern terms, compounds. As evidence, it is mentioned that maggots are produced from old meat, and yet those maggots were clearly not part of the meat originally, but have somehow been created from it. Neither the meat nor the maggots are prime materials. Carnitis also presumes that lead and gold are mixed bodies, and points out that they are not separated into elements by simple fire. It is worth noting that at the time, the main evidence that lead and gold were elements was actually that they were not separated by fire. Patterson Muir, in his introduction to the copy of the Skepticchymist that I am working from, states that in many senses this argument contributed to by Boyle between the 4 elements and the 3 principles is of little interest in the early 20th century, as both are known to be false. However, the point I find most interesting in the Skepticchymist is not the specific models that are being proposed, but the kinds of arguments and evidence, and the fact that they are not different in kind from the arguments which, over the next 200 years, led to the determination of roughly 100 prime materials or chemical elements being the standard model of chemistry. Similar arguments occurred during the mid-20th century over the question of what was the right collection of subatomic particles. The skeptical chymist is a microcosm of the arguments about chemistry of the next couple of centuries, prior, as stated, to the advent of quantum chemistry, but also after in terms of fundamental particles. Carnitis then concludes the chapter by stating that there are other cases of application of heat that produce more than 4 distinct-looking products. He mentions blood, which he says produces phlegm, spirit, oil, salt, and earth under distillation. The next chapter is called the first part. Carnitis then attempts to use the axiomatic method, starting with the first proposition in the style of Euclid. Proposition 1. It is possible that the universal matter is divided into particles of several sizes and shapes. A curiously hesitant axiom. The idea that matter is divided into particles of different size and shape is claimed to be not impossible. However, I take it that this is intended to be the axiom for the theory that matter is actually divided into particles of different sizes and shapes. However, it is not self-evident that this should be so. Proposition 2. Neither is it possible that of these minute particles, diverse of the smallest and neighbouring ones, were here and there associated into minute masses or clusters, and did by their coalitions constitute great store of such little primary concretions or masses as were not easily dissipable into such particles as compose them. I think this means that the minute particles can be combined in such a way that it is impossible to separate the materials out into its components. Carnegie then states that since gold can be combined with things and then separated out again and be the very same amount of gold with the same nature, that it is evidence that the gold has remained in some sense gold in the combination. While this is not taken as evidence of the elementary nature of gold, it is taken as evidence that it is tightly bound combination of some of the primary materials. A similar argument was made by Skepticchymist in Summa Perfectionis. Eleutherius then says that the 4 elements could be combined into an infinitude of mixtures, and Carnitis agrees but points out that the same is true of the 3 principles. Proposition 3. Carnegie won't deny that the animal tissue might be separated into any number of substances by fire. And there it is again, that continued assertion of failure to deny. Proposition 4. When some material is separated into distinct materials, those materials may be called the elements or the principles of the original material. For my money, Boyle seems to be siding with Carnitis, but the propositions are not anywhere near as clear or as decisive as I think Boyle thought that they were. However, there is something of a point that I'd phrase differently. Suppose we have material that is isolated in a non-reactive chamber and then heated, and that material breaks apart into several materials. Then we can say that those materials are components of the original material. This kind of point was also made by Skepticchymist. A strong mixture is some material that is not broken apart by heat. But can we call it an element? Skepticchymist thinks not, and maintains that the elements or primary materials are earth, water, air and fire. On the other hand, the strong mixtures mean about what the term chemical element meant by the 19th century. That is, this is really 2 different meanings. On the one hand, the elementary or prime materials that cannot in any sense be broken apart, created or destroyed, and on the other hand, the chemically elementary materials that cannot be broken apart by chemical means. And of course, the complication that potassium was found using electricity, not chemistry. On an entirely practical note, later in the 18th century, some parts of the argument about phlogiston revolved around whether the chamber in which the material was contained while heating was truly neutral or was instead contributed to the products. Between 1768 and 1773, Lavoisier conducted and reported on an experiment in which he heated water for 100 days in a sealed glass vessel. He found a white residue which some claimed was the water turned to earth. He weighed the water, the residue and the earth and found that the drop in weight of the vessel equalled the weight of the residue. This was taken as a demonstration that the water was not turning into earth, and at that time it appears that Lavoisier had the notion that water was an element rather than compound with earth. Later he changed over to water as a compound of hydrogen and oxygen in the modern mode. See also A.N. Meldrum, Lavoisier's early work, 1763 to 1771, Isis, Volume 20, Number 2, January 1934. Experimental science is a long way from being straightforward. You can't usually go and look. Just doing an experiment does not typically resolve the matter, as the context of the experiment is always uncertain at some level. Also, if a material is heated and then new materials appear, rather than validly being components of the old material, the new materials might be new combinations of the elements of the original material. However, Carnitis does admit right away that the matter of calling these products elements or principles is not entirely justified. That is fine, but it makes me wonder whether any real propositions are being made here at all. Carnitis then proposed doubt about whether heat is the universal tool for breaking materials apart into the prime materials. As we know from the work of Davy a couple of centuries later, electricity also plays a role here. In particular, guajacum, when burned in the fireplace, produces soot, but when distilled in a retort, yields other materials. The details of this kind of behaviour are then expanded on. I had to look up guajacum, which turns out to be a genesis of flowering plant that contains a variety of slow-growing trees of about 10 metres in height. The name was brought into English in 1533, being the first English word of American origin. The point is a good one. Different methods of decomposing a material can produce different seemingly homogeneous elementary materials. However, this gets back to the basic point that when a material is apparently decomposed, it might rather be a case of the truly elementary materials are being rearranged, like quarks in the 20th century particle theory, without any chance of ever seeing the pure form. However, Boyle then uses the word flower in a manner that I would like to explain, as it was one of the first unfamiliar words used in old alchemy and chemistry that I became familiar with. Carnegie says, but not here to mention what I elsewhere take notice of concerning common brimstone once or twice sublimed, that exposed to a moderate fire in subliming pots, it rises all into dry and almost tasteless flowers, whereas being exposed to a naked fire, it affords store of a saline and fretting liquor. Not to mention this, I say, I will further observe to you that as it is considerable in the analysis of mixed bodies whether the fire act on them when they are exposed to the open air or shut up in closed vessels, so is the degree of fire by which the analysis is attempted of no small moment. End of quote. While a noticeable time is spent by me here on attempting to show that alchemy smoothly merges into chemistry rather than being distinct ideas, this is not really my central goal. Most of my goal is to understand the details of the older theories of matter, and the changes in terminology over the last 1,000 years have, not surprisingly, been an obstruction. Boyle refers to dry and almost tasteless flowers. I first heard this term in Flowers of Antimony in some work or other. I think it was Priestley. From looking up old dictionaries, I find that it has a clear meaning. When a material is heated, some of it turns into gas, perhaps directly, and this part is said to have sublimed. It then deposits as a flower. Cyclopedia, or a universal dictionary of arts and sciences containing the definitions of the terms and accounts of the things signified thereby in the several arts, both liberal and mechanical, and the several sciences, human and divine, 1728, volume the first. The Chambers Cyclopedia is a 2-volume work by E. Chambers, of which I have access to all 3 volumes. Flowers of Antimony is antimony pulverized and sublimed in an aludel, the volatile parts whereof stick to the subliming pot. See flower and sublimation. This is also a powerful vomitive, of singular efficacy in maniac cases, being the Herculean remedy by which some have gained so much reputation. The gas is then allowed to pass up through a hole in a flat plate, and the drop in temperature on the other side causes the material to deposit on the surface in a shape that has something of the appearance of a flower, hence this use of flour rather than the related use of butter, which means yellowish, oily material, is practical and descriptive and not primarily poetic. Similarly, body is the material that is left behind, that does not sublime, and soul is the material that is given off. without any intention of claiming the material is a living creature. It's just jargon. At this point, the focus of the narrative narrows down on the details of the different substances. This being of potential interest in and of itself will be left for a later essay.